All right, so this is chapter 1.3, part 2. I'm recording this on Friday while we have our parent conferences. So if I have to pause because somebody comes in, just know that that's why. So on the previous lesson, we talked about horizontal and vertical translations. Okay? And today we're going to talk about reflections on the x-axis and the y-axis. So most likely this is Monday. And it's the lesson for, let's see, it's the 11th, so 12th, 13th, 14th of 2020. The objective is, I'll put I will, because it's really about you. I will be able to write an equation given a reflection over or in, okay, the x and y axis. So you would be a level 4 if you can do both the reflections over the x and y axis. And you'd be a level 3 if you can only do one of them. 2 would be maybe that you have some struggles setting them up, but you get the idea of where you need to go. Okay. So keep that in mind as we do this. So the rule about the reflections, okay, is first of all, a reflection is like a flip. So say this is my graph. Okay. Normally our quadratics point up, so these little ends point up and it makes a U. When it's reflection over the x-axis, it flips down like an N. Okay. You can also have graphs that flip over the y-axis. The problem with parabolas, though, or quadratics, is that when you flip them over the x-axis, because they're symmetrical, sometimes it's hard to know if it's actually flipped over the axis unless it's been scooched over. And then you would see that it visually flips from like quadrant 1 over to quadrant 2. Okay. So a reflection in the x-axis is y equals negative f of x. Okay. And this might be hard for you to draw it out unless you have multiple colors. So this is my x-axis and this is my y-axis. Okay. If I had the linear parent goes through 0, 0, slope of 1. Okay. So this is my parent. Okay. And if we call this one y equals f of x, okay. Then if I were to flip this over the x-axis, okay, this part would flip that way, and this arm would flip that way because this is below the x-axis, so it's going to flip above it. Okay. Also, the points are like mirror images of each other. So see how this one is 2 away? It would be 2 away down here. This one is 3 away. It would be 3 away down here. You should have done something like this in geometry with shapes. Okay, it's that same idea. Okay, so then this new equation would be y equals a negative f of x. Okay. I'm going to write a note to ourselves that multiplying the output by negative 1 changes signs, which is why if the output was a negative y, it's now becoming a positive y. Okay. And again, if you're watching this video, you can pause it so that you can copy down notes and you can rewind it. If I'm going to reflect over or in, the y-axis, instead of the negative being outside here, the negative is inside. So it would be y equals f of negative x. Okay, and you're going to say multiplying the input, so inputs are x's, by -1 changes signs. Okay. And this actually is going to end up looking similar to this because of how the graphs are. But the way that you're going to think about it happening is a little bit different. I'm going to scooch mine here. So say this is y equals f of x. So it's just a random one. It's not the parent. Okay. But I haven't given you any values. Okay. This one is approximately at 2 away from the y-axis. So it's going to be 2 away from the y-axis over here. Okay, this one is approximately 1, so it's going to be approximately 1 here. This one is on the y-axis, so it's going to stay there. And this would be my new graph. So to do this reflection, okay, I counted how much it was from the y-axis, whereas up here, I said how far is it from the x-axis, and I went that way. Okay, so when I'm talking about it in terms of it reflecting over the y-axis. Okay. Again, this won't happen when you have certain shapes, but they look very similar for linear functions. All right. Okay, so we're going to do example 1 for the day. And you can find all of these in our math book, which is available online. Okay. It says, let f of x equal the absolute value of x plus 3 plus 1. And so you should start to be able to recognize that's going to make a sharp V shape. And you could put it in your calculator to look at it, and that's fine. Okay. But we're going to do part A first, which is write a function g whose graph is a reflection in the x-axis of the graph of f. Okay. So what you're going to want to do is say, okay, it's reflective of the x-axis. You'll flip to your notes. You'll say, okay, reflection in the x-axis. I'm going to use this rule. Okay. I'm going to have a negative out front. So the rule is y equals negative f of x. Remember, f of x is that function there. Okay. So then we're going to have my new function g is going to be equal to negative parentheses. And I have to write in everything that f of x had. That's why we have to use parentheses, because it's a little bit more complicated. So I have x plus 3 plus 1. Okay. And we're going to have to do the distributive property. Okay. So this negative needs to go to each part. Oh, I forgot of x. Sorry. Here. So g of x equals negative absolute value bars x plus 3 minus 1. And that's all you do. This is your new function. Okay. And if you put it in the graphing calculator, you can check it. Okay. B is the same thing. Okay, but we're going to write a function h. Okay. So same equation, same function, but we're going to reflect over the y-axis. So I would look at my notes, and I say, oh, that's inside. So my rule is y equals f of negative x. Okay. So now everywhere I see x in my original function here, I'm going to replace it with a negative x. Okay. Because we're substituting in this value. Up here we didn't do that because x was x. There was no change to our original. Okay. But here it says we need to replace it with a negative x. So I'm going to write, what is our new function called? H. So h of x equals absolute value bars, negative x plus 3, absolute value bars plus 1. And all we did was replace. Okay. Now, something that's interesting about absolute value functions is that we actually don't allow the variable here to be a negative. You always want it to be positive. So what we do is we factor out a negative 1. So if we take out a negative 1 from each of these, the signs change. But there's what's called the product property of an absolute value. And I'm just going to tell you when we go over these to just change everybody's sign inside if you have a negative, because that's basically what you're doing. So your final answer is h of x equals the absolute value, and it's a positive x and a minus 3 plus 1. This would have been something they would have taught you in Algebra 1, but I'm not sure we always get there due to time. But basically, it's just change the signs that are inside here if your variable ends up with a negative, and then you'll be okay.